So this is 3.2a, Rolle's theorem. Before you do anything, I want you to put like a little graph, and I want you to put 1, 3, and 7, 3 on the graph. I want you to put 1, 3, and 7, 3 on the graph. So the two y values are the same. And then I want you to sketch a curve, a nice smooth curve to connect the dots, however you wish. However you wish to connect the nice smooth curve and connecting the dots. And Becca's going to be in charge of mine. All right, connect the dots with a nice smooth curve. Make sure it passes the vertical line test. Oh, she crazy. All right, perfect. I love it. All right, I love it. So now what we need to see, is there at least one point, I got to count here. There's at least one point in which my derivative is 0. What does it mean to have a derivative of 0? A horizontal tangent. So basically I'm trying to figure out, is there at least one point in which I have a horizontal tangent? Yes. How many do I have here? 1, 2, 3, 4, 5, 6. We had 6 of them there. All right. More than likely, the one you drew was probably not 6. All right. However, did you have at least one? Yes. All right. Most people might do something like this. How many would you have on that one? 2. Okay. Or somebody would probably do something like that. How many would you have there? 1. But you would have at least how many? 1. All right. Very good. So let's talk about Rolle's theorem. Now, I'm going to completely be straight up with you. Rolle's theorem is not as big as intermediate value theorem and extreme value theorem. However, it is a theorem. Now, tomorrow's lesson, that's another big one. All right? So we should still write this down because it will lead in to what we're doing tomorrow. Okay? All right, so let's read Rolle-Polle's theorem, and Ansley's going to be our reader.
Let f be continuous on the closed interval of a, b, and differentiable on the open interval a, b. If f of a equals f of b, then there is at least one number c in a, b such that f prime of c is 0.
All right, fantastic. Now, this is our first theorem that says a certain word that is unlike the other two that we've experienced. Intermediate value theorem, what was that? Let's go through them again. Intermediate value theorem, what happened? What had to happen in the function? It had to be a continuous, all right? And then what? Then what happened in the function? Riley, you were talking about?
The point occurs when this value occurs within the function.
The two y values were different. There was something in the middle, all right?
They had to not.
And then extreme value theorem. In extreme value theorem, again, that function had to be what? Continuous. It had to be continuous. All right? What does this one have? It has to be continuous, but also what? Differentiable. All right? Now.
And we also have to have f of a and f of b equal to each other.
Exactly. All right? Now, but this is our first one that it has to be differentiable. Now, on Rolle-Polle's theorem, f of a equals f of b. What does that mean? No, what does f of a equals f of b mean? The y values are the same. So they're at the same height. Okay, the one we just did on the other page was they're both at 3. All right, they were both at 3.
But listen, it's also an existence theorem.
This is an existence
You're
theorem. You're right. All right. So then it basically says that f prime will have to be 0 at least one time. All right, that's what Rolle-Polle's theorem is doing. All right, so this is our first one that we have to be differentiable. Now, on this one, can I actually use Rolle-Polle's theorem?
Yes.
Yes. Can I use Rolle-Polle's theorem? No. Why not? It's a sharp turn. It's not differentiable there. Okay, pretty good? All right, let's keep moving. So here we go. Let's put this into practice. So we're going to find the two x-intercepts of this quadratic, x squared minus 3x plus 2, and show that f prime is 0 between those two x-intercepts. So did this actually give me an interval?
No.
No. My interval is going to be my x-intercepts. Does that make sense? All right. So we need to find those x-intercepts. What do we like to do to quadratics? F them up. So We f it up to what?
X minus 2x.
X minus 2 and x minus 1. All right. And so we end up with x equals 2 and x equals 1. So basically, my interval is between what? 1 and 2. Now, is a polynomial going to be a well-behaved function? Is it going to be continuous and is it going to be differentiable? Yes. All right. Those are nice, well-behaved. All right. So what do I need to do? I need to take a derivative. Now, honestly, I should show that these two are equal. So I really should show that f of 0 or f of 1 is 0 and f of 2 is also 0. By Rolle-Pole's theorem, I should show that I have the same y values. All right. And so what is f prime? 2x minus 3. And what are we going to do with this 2x minus 3? We're going to set it equals 0. So what do we get?
3/2.
X equals 3/2. And what Rolle-Pole's theorem says is that f prime of 3/2 will equal 0. All right. Now, did this one necessarily ask for the point in which it was a horizontal tangent? It did not. It just had to prove it. All right. I want to go further. I want to actually find the point. Does Rolle-Pole's theorem ask for the point? No, but I want to do it. All right. So if we substitute back in. So now I substitute back into the original. So if I have 3/2, what's squared? 9/4. Then minus 3 times 3/2 is 9/2. So how do I really want to think of that? 18/4. And then how do I want to think of 2? 8/4. And so I end up with negative 1/4. So what is happening at 3/2 comma negative 1/4? I have a what? I do have a slope of 0. That's true. But I have more than that. I have a horizontal tangent. True that. But what's really happening? What did I just get there? A relative what? Minimum. I had a relative minimum. All right. And honestly, that was an absolute minimum as well. All right. Pretty good? All right. So now we have this function. So now we have the function x to the 4th minus 2x squared. And we need to find all the values on the interval negative 2 to 2 such that f prime is equal to 0. So basically they're saying, find Rolle's theorem. Right? That's really what they're saying. So if we're going to use Rolle's theorem, we need to figure out if the y values are the same. So let's substitute in. So f of negative 2. What is negative 2 quantity to the 4th?
16.
16. And then 2 squared is 4. 4 times 2 is 8. 16 minus 8 is 8. So what is f of 2? 8. All right. Now, I know this isn't happening today. But I kind of want to preview what's going to happen tomorrow in the later days. What is the slope between these 2 points? 0. And what are we going to do with our derivative? We're going to set it equal to 0. Okay, good. All right, I just want you to think about that just a little bit. So I'm going to take a derivative. So f prime of x is equal to 4x cubed minus 4x. So what am I probably going to do with that thing? F it up. So I take out a 4x and a, what am I left with? X squared minus 1. And I'm going to set that thing equal to 0. Now, we're using Rolle's theorem, so we're going to set it equal to 0, but truly, we might be setting it equal to 0 because the slope between those 2 points is 0. Okay, cool. All right, so when I set that thing equals 0, I get x equals 0, x equals 1, and x equals negative 1. So if I'm purely showing Rolle's theorem, I should say f prime of 0 is 0, f prime of 1 is 0, and f prime of -1 is also 0. I know it's fairly redundant, but that is using that theorem. So there we go. Now, if we wanted to find the points, what could we do?
Substitute.
We could substitute back into the original. All right. Pretty good? All right. So on Rolle's theorem, real quick overview. What do? We find the two y values that are the same. And then we take a derivative and set it equals 0. But what does the function have to be? Continuous and differentiable. All right, get working on this.